Hello, Anna.
Hello, sir.
Anna, am I audible?
Yes, sir.
All right, everything good?
Yes.
All right, any doubts from the last class?
No, sir.
All right, let's start.
Sir, I was just thinking that for me, intervals is not coming in the test, and I have a test on June 19 right now. So, if you're good, can you please do trigonometric ratios? We just
June
pause.
19. All right, what are the topics that are coming in the examination?
So, for me, in the textbook, sets is actually coming like half chapter, and this trigonometric ratios is coming till exercise 3.23. Like 3.3 first question. That's all.
All right, all right. Okay, so just trigonometry and this sets, right?
Yes, sir.
All right, don't worry. Till then, we'll complete by all the topics that are coming in the examinations. All right. Intervals are very small topic. We are not going to learn this in complete detail. That we are going to do in inequalities. All right. This is
Okay,
an introduction. All right, Anna.
yes, sir.
All right. So, what are intervals? They are subsets of R. R means here real numbers. All right. Suppose if I have to mention that I need all the numbers from 3 to 9. All right. How I can write that? I can say that all the numbers A, B, a set, all the numbers from 3 to 9, all the real numbers from 3 to 9, or what we can write I can write this. All right, or this. There are three kinds of intervals. Don't write this. All right, this is just to explain you three kind of intervals. This is called closed intervals, open intervals, and semi open or semi closed intervals. All right, this is the right intervals. So first one is closed intervals. All right, if I write A of all x such that x is greater than equals to A but less than equals to B. All right, and x belongs to real number. That means all the numbers that start from A and end with B in between, right?
Yes, sir.
So this we can write as closed interval is square brackets A comma B. A comma B means start from A, including A, go till B, end with B. All right, both are included. That is called closed interval. So
Okay.
if I write 1 comma 5, that means in the number line this will be equals to 1 to 5, all the numbers between them, including 1 and 5. All right,
Yes, sir.
you can note it down. Close intervals.
Done, sir.
Next one is open intervals. Here A is equals to x such that A is less than x is less than B. Here A and B are not included. Everything remains same. Just A and B are not included. So we can write A equals to 1 comma 5. So in the number line 1, 2, 3, 4, 5. 1 and 5 are not included. Everything else is included. This is clear?
Yes, sir.
All right. Note it down.
Done, sir.
All right. Now semi-open or semi-close. This is the combination of two. If I write a comma b, this one, or a comma b, this one. This is also semi-open, semi-closed, semi-open, semi-closed. This will mean, can you tell me what this will mean?
This will mean A is not included, but B is included.
Absolutely right. A is not included, but B is included. And in here, this is A is included, but B is not included. All right. Wherever you see square brackets, that means that number is included. All right. And parenthesis means not included.
Yes.
Note it down.
That's
All right. Now write down singleton set. Give me a second.
so what?
Nothing. All right. Singleton set. So what is singleton set? Singleton set is where the name says itself, where only one element is there in the set. All right. Let A be a set such that only one element is there in A. Then A will be called all right, Arnav, this is very clear.
Yes, sir.
Very easy also.
Yes, sir. Done, sir.
Next is universal set. A set that contains all the sets in a given context is called universal set. Write it down, then I'll explain what this is about.
Done, sir.
So what this means is, suppose I mentioned that there is a set 1, 2, there is set B 2, 3, 4, and C right? 4, 5 and 6, suppose. All right, this is a given context. Given context means now I am dealing with A, B and C. So here universal set U will be all the elements 1, 2, 3, 4, 5 and 6. All right, which contains all the elements in a given context is called universal set. All right, and
Yes, sir.
all right, you written this down.
Yes, sir.
All right. Power set. The collection set of all the subsets of set A is called power set of A. It is denoted by here. What this says? This says that suppose there is a set A 1, 2. Its subset will be 1, 2, 1, 2 and 5. Right? These are all the subsets of A. If I create a set of all these sets as the element of this set, then this will be called power set of A. All right, creating a set of all the subsets of A is called power set of A. Is it clear?
Sir, in this, do we also mention like each set separately? Like,
Yes.
or we just
See,
make it one set?
always. Yes, see, because a subset is a set, right? If you have a set B 3, 4, 5, then each subset will be a set of itself, right? Each
Yes.
element is in a set in subsets. So all the elements will be sets in the power set. All right.
Yes.
This is clear now. This was your doubt, right?
So if we like in power set A, if we remove the brackets, then it's a universal set. And if we put the brackets, then it's a power set.
No, 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 no. This is not universal set.
For one, you have put two brackets, right? So if we remove those brackets for 1, 2, and 1 and 2, then it becomes a universal set. And if we put those brackets, then it's a power set.
No, 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 no. Don't think it like that. See, universal set. If you have to, there is a set A where 1, 2 is the only elements, right? If you have to put you have to write the universal set, then you will mention that U is 1, 2 only. You don't have to write 2 times or 3 times or anything like that. You just have to write all the elements in a given set. All right.
Yes, sir.
But in power set, what is happening? First, you write all the subsets of A. All the subsets of A. All right. Subsets first will be 1, then 2, then 1, 2, and 5. These are all the subsets of A. Right, Arnav?
Yes, sir.
Now you have to make a set out of these elements. Take these as elements of this set, and this will be called power set of A. All right.
Yes, sir. For this only, I'm saying that you have put two brackets on 1, 2 brackets on 1 and 2, and 2 brackets on 2, right?
Right.
So if we remove these inner brackets, then it becomes a universal set because it contains all sets with all the elements which are in A.
Right. Right. In this scenario, this becomes the universal set. All right.
Yeah.
But don't think like that there is a relation. All right. There is no relation as such. It's just that in this case, this becomes a universal set. All right.
Okay. Yes, I've noted it down. We can go.
Sorry.
I've noted it down. We can go to the next one.
All right. Cardinal number of a set.
What?
Cardinal number of a set. Cardinal number means the number of elements in a given set is called cardinal number of that set. That's very easy. How many elements are there? That is called cardinal number. All right. Sometimes they write it as cardinality, and we write that suppose a 1 2 3 4 5. We mention this as n of a, number of elements of a. This you have to write 5 because we have 5 elements. All right.
Yes, sir. So there'll be 6 elements because 5 is also a part.
No. We don't write 6.
5 is only considered as a subset.
Right. That is only a subset, not an element.
Okay. Sir. Okay.
All right. Now let me give you a question. If a equals to a comma b comma c, then what would be n of p of a? All right. Think about this. Tell me the answer.
What is n for?
This I just mentioned cardinality, right? Have you noted this down? Cardinal number of set.
No, sir, just a second.
All right. We denote that cardinal number as n of set A. All right.
Yes, sir. It's 3.
3. How is it 3?
So because there's 3 sets in the power set, there'll be 3 AB, BA, and AC.
No. See, if you have to write all these subsets of A,
Yes,
first will be only A
okay.
subsets, right? Then
So
B
it will be
and
6.
so on. Not 6. Remember that formula I told you in the last class? If A has 3 elements, then total number of subset is 2 raised to the power 3. All right. So this is very useful formula in this type of questions. Did you say anything, Anna?
Yes, sir. But then it's A, B, and C, and then AB, BA, and AC. There's 2.
Right. Then
What will be the 2 other?
let me tell you: AB, BC, and AC.
Yes.
ABC, all of 3, and no one 5.
So
These are
but
the 8 subsets.
ABC is already the set. So it's not a subset, it's an equal set.
Right. I told you in the last class. Remember, I gave you this note that each
Oh,
set is a subset of itself.
yes, yes,
Right.
yes.
So we can say that this is also a subset of this set.
Yes.
5 is a subset of this set also. All
Yes.
right.
Yes, sir.
So whenever you see this type of question, number of elements in power set of A, they are not asking you to write the power set. They are just asking you how many elements are there, right? Indirectly, they are asking you how many subsets of A are possible, right?
Yes, sir.
So you just have to use this formula that in the power set of A, we will have 8 elements. So n of p of a will be 8. Clear?
Yes, sir.
Don't forget this formula, very important formula. Now let me make this a little bit tricky. If a is a comma b, then p of a. All right, n of p of a. What this means? Power set of a. How many elements are there in power set of power set? All right.
Yes, just a minute.
Take your time. Just don't be in a hurry. Do this very carefully. Tell me the right answer.
Sir, it's 16.
How did you get 16?
Sir, because A has 2 elements, so power set of A will have 4 elements. Then
Absolutely right.
power set of A will have 16 elements because there are 4 to 2 to the power 4 is 16.
Absolutely right. So this is absolutely right answer. So this type of question is clear, right?
Yes.
Don't forget this. Note it down if you have not.
Just a second. Done.
All right. Now let's learn about Venn diagrams. What is the definition of this? See, most of the relationships between sets can be represented by diagrams, which are called Venn diagrams. All right. We generally use rectangles and closed curves, usually circles, to represent sets. Universal set is represented by a rectangle and circles are drawn for its subset. Right? What this says is Venn diagram are nothing but the way to represent the sets in diagrams. All right. So what do we draw in these diagrams? We generally use rectangles and circles. All right. Rectangles represent universal and circles represent subsets of this, subsets of U. All right, Arnav?
Yes.
So for an example, if we have a set U 1, 2, 3, 4, 5, 6, and a set A 3, 4, and a set B 1, 2, then this we can represent in Venn diagram as this is U. All right, this is U rectangle. Now A and B. Here we have 3, 4. Here we have 1, 2, and all the remaining elements in U. All right. This is Venn diagram.
So it's also drawn by joining two circles, like there's a common space between two circles.
Right. If there is any common elements, then we can write by joining. Suppose in another example, A is equals to 4, 5, 6, and B is equals to 5, 6, 7. All right, and U is 1, 2 till 8. Then what we have to do is join the circles, because we have two common elements. The common elements will become in the common part. All right, here 4, this is 7, and rest of those 1, 2, 3, 8, all of this will be in U. All right,
Yes.
so these are the common parts. Note it down.
So can you scroll down? So a little down. Okay, so done.
So this is about Venn diagrams. All right.
Yes, sir.
Now operations on sets. All right. What are the basic operations that we can perform on sets? The first one is union. All right. The union of two sets, set A and set B, is the set which consists of all the elements of A and all the elements of B. The common elements being taken only once. Right? Union is represented by the symbol U. Symbolically we write A union B. All right. See, what is union? You take two sets. All right.
Yes, sir.
Let me give an example. Suppose A set is 1, 2, 3, and 4, and B set is 3, 4, 5, 6. All right. If you have to take union of both A union B, this is read as this A union B. Then what you have to do is put all the elements of A here, 1, 2, 3, 4. Then all the elements of B also. But the common elements we have to write only once. All right. So only 5, 6. Is it
So
clear
then,
or not?
so what is the difference between union and universal set?
Right.
Because universal set is also the same thing.
Right. But see, suppose we have a set C also, 7, 8, 9. Now universal set will be different from A union B, right?
So how?
Because that will also consist of 7, 8, 9, right? From 1 to 9, we'll have all the elements in universal set. If we have another set D, which 10, 11, 12, so universal set will have all the elements from 1 to 12, right?
Yes,
But
sir.
A union B only have 1 to 6. Is it clear
But
now, Arnav?
it can, union can basically be told as a part of a universal set.
Right. We can say that union is a part of universal set. All right. Everything we are dealing in 2 sets or 4 sets is always a part of universal set, because universal sets consist all the elements, right?
Yes, sir.
All right then. See, just because something matches with the universal set doesn't mean there is a relation. All right, enough. We are taking just a few examples, right? So there may be coincidences where two sets match. All right.
Yes.
So write it down. This is clear, right? This is nothing but, see, if you have 3 sets and you are taking a union of them, take a bag, put all the elements of these 3 sets in the single bag. That is union. All right. You have to take all the elements and put them in a single set. All right.
Yes, sir.
Just don't repeat these elements.
Yes, sir.
All right. Note it down.
Done, sir.
All right. Solve one question. If we have a set A, B, and C, and set B, A, E, I, O, U, and what will be A union B? All right, this is the question.
So it repeats A, E, I, O, U, right?
Yes, these are the vowels.
So A union B will be A, B, C, E, I, O, U.
Absolutely right. All right, all the elements where the common elements are written only once. This is clear?
Yes, sir.
No issues, right?
No, sir.
So there are few properties of union. All right. Can you tell me what is commutative property?
Sir, what?
What is commutative property?
Sir, the order in which you add does not matter.
Right. So this is commutative. A union B is equals to B union A. All right.
Yes, sir.
And this is also associative, right? It doesn't matter who you associate with first, the end result will be same. All right.
Yes, sir.
And this is there is no need to explain this, right? Because we are going to just put the elements in a bag. So if you put B first or A first, doesn't matter. All right.
Yes, sir.
Now this, think about this and tell me the answer. What will be A union phi?
A union 5 will be nothing.
Nothing.
Yes, sir, because there's no common elements.
Then in union, do we take the common elements?
So it will be A, B, C.
Where did you find ABC?
So it's in A.
No, no. A is just a set. I have not given you any elements or told you about the elements.
Okay, sir. So it'll be all the elements of set A.
Absolutely. Right. So the end result will be set A only, right? Can we say this? A union phi is A.
Yes, sir.
All right. Now A union A. What will be A union A?
So A, set A.
A. Absolutely right. Now this uses universal set. Universal set union A.
So all the elements in the universal set.
So we can say this is U. All right. U is the universal set. This is clear.
Yes, sir.
All right. Note it down.
Yes.
Done, Arnav?
Just a second, sir.
All right.
Done, sir.
All right. And you told me your exam is on June 19th, right?
Yes, sir. So I just got the updated circular. It's sets full chapter and trigonometric ratios. It's still exercise 3.3.
3.3.
Like everything before that.
I think we'll not be able to complete till 3.3. We'll take at least.
So actually you can speed up because for me, on trigonometric ratios is done and sets is going on. Trigonometric
All right.
ratios that part is done, so you can just quickly go through it.
All right. Then no issues. But see, actually, we'll have other students join also, right? So we
Yes,
have
yes.
to go in the detail. But if it is done, then good for you, right? We don't have to see.
Yes.
If you have any doubts, then you can ask me after the classes. All right. If you have few topics, but we'll
How,
cover in detail. Sorry, what?
how can I ask you?
See, whenever we complete the class, after that you can be with me for 10-15 minutes. All right. And if you have doubts in trigonometry, we can discuss that.
Yes, sir.
All right. Because you are saying that is completed, right?
Yes, sir. The portion for the exam is completed.
All right, then we'll do this because in the class we have to keep the pace with
Yes,
other students, right? So
yes,
that
sir.
they'll be able to understand. And sets will be completed properly in the next week. And in the week after that, I'll start trigonometry. All right.
Okay, sir.
All right, then now see you in the next class. This is all for today's class. I hope you understand everything, understood everything. All
Yes,
right.
sir. Yes. Thank you, sir.
All right. Take care.